All good so far? Let's try another one. Let's try prove P implies, not P implies Q. So write my goal down the bottom. And I'm given nothing this time, so I have to start from nothing. Well, it's an implication, and we know how to deal with implications. Assume the left and derive the right. Assume P, derive not P implies Q. Oh look, another implication. Assume the left, derive the right. I've got P and I've got not P, so I can get false, but it's not immediately obvious how to get from false to Q. So the sneaky trick is, this is called principle of explosion. If you have false, you can prove literally anything. And here's the magic trick. To try and prove Q, we do so by assuming the opposite. So I assume not Q, try and obtain false, and therefore Q. Now hold on, I've already got false. I can steal the false from above. So the proof is done, so we can fill in our line numbers and our rules. 4, 5, 6, 7, 8. That was an assumption, that was an assumption, that was an assumption. So you can see, if you're working top down, 3 nested assumptions, how would you know how to do that? But by working bottom up, the proof sort of structures itself. So assumption, assumption, negation, elimination, lines 1 and 2. This is an assumption. This is a repeat of line 3. I can just steal the false down. I assumed not Q. I derived false, therefore Q. By proof by contradiction. PC, lines 4 through 5. I assumed not P. I derived Q, therefore not P implies Q. Implication introduction, lines 2 through 6. And then same again. I assumed P. I derived not P implies Q, therefore P implies not P implies Q. By implication introduction, lines 1 through 7. Okay? As a problems for you to solve, I'd like you to try and solve both the problem from the tutorial sheet. So P implies Q, implies not Q, implies not P. This is sometimes called law of contrapositive. I'd also like you to prove the opposite of what we've shown here. We've proven that P implies not P. I'd like you to prove that not P implies P. Okay? So I leave it to you to solve those.